We often hear people saying you can't compare apples to oranges. But in statistics, you can. Not only can you compare apples to oranges, you can also compare mangoes to guavas, kiwis to cranberries. How? Through the magic of Z-scores. Z-score is a pure number with no units attached to it. For example, number 2 or 3.4. In contrast, you have units attached to something like weight that is expressed in pound or kilogram. Height has a unit attached to it, such as inches or feet. But a z-score is a pure number, which is what allows us to compare apples to oranges. So, for example, here's how this is done. Who is taller, a man 73 inches tall or a woman 68 inches tall? The obvious answer is that the man is taller. However, men are taller than women on the average. So that's not a fair comparison. It's like comparing apples to oranges. That doesn't work in this case. But if the question is asked this way, who is taller relative to their gender, a man 73 inches tall or a woman who is 68 inches tall? And the answer to this question can be done with a z-score. So how does z-score work? The National Health Statistics states that the mean height for adult men in the US is 69.4 inches. This could be, for example, a sample of 1 million adult men. The mean height is 69.4 inches. But not all men have the same height. So how do we measure the spread in the height of men? That is captured by something called the standard deviation, which in this case happens to be 3.1 inches. It's a single number that summarizes the spread of the data, in this case the height of men, from the mean, the average spread. The mean height for adult women is 63.8 inches, again with a spread or a standard deviation of 2.8 inches. So the question is, who is taller relative to their gender? A man who is 73 inches tall or a woman who is 68 inches tall? So the z-score formula is very straightforward. It is simply the difference between the raw score and the mean for that particular group divided by the standard deviation. So notice that the man is 73 inches tall. The mean height for his group is 69.4. So the difference between this, which is in inches, divided by 3.1, which is also in inches. So the inches and inches cancels out, and you're left with a pure number, which is 1.16, which simply means that the man with the height of 73 inches is 1.16 standard deviations above the mean in his group. For the women, the z-score is the same formula, 68 minus 63.8, 68 being the height of the woman. So it is this difference in inches divided by 2.8, which is also in inches. And once again, the inches and the inches cancel out, and you are left with a pure number 1.5, which simply means that relative to her group, the woman's height is 1.5 standard deviations above the mean. So now we compare these two numbers. Previously, this 73 and 68, this was the apple, that was the orange. But now we have reduced the scores to z-score, which is 1.16 and 1.50. It is not inches because inches has cancelled out. So who is relatively taller? Because the z-score is 1.5 for the women, she is relatively taller compared to the men, even though her actual height, 68, is less than 73, but with respect to her group, she is relatively taller. So that is how, by converting a raw score to a z-score, we are able to compare apples to oranges. So can we compare apples to oranges? Yes, in statistics. How? By using the z-score.